Hello, my name is Quinn Lippitz, and I am presenting on my research on the relationship between economic development and environmental degradation. So during my research, I was looking at the environmental Kuznets curve, which is an economic model which shows the relationship between economic development and environmental degradation. The environmental Kuznets curve is derived from the Kuznets curve, which originally shows the relationship between economic development and inequality within a country. The environmental Kuznets curve has been adapted to show the relationship between economic development and environmental degradation, typically using income or GDP per capita as the measure of economic development, and usually pollution per capita as the measure of environmental degradation. It is a nonlinear model in the quadratic form, typically in what's referred to as an inverted U shape. The model breaks the types of economies that a country can have into three different sectors: primary sector, which is a pre-industrial economy; secondary sector, which is an industrial economy; and tertiary sector, which is a post-industrial service-based economy. Based on the type of economy that a country has, the environmental Kuznets model predicts what the relationship between economic development and environmental degradation will be. In the first sector, within a pre-industrial economy, the model predicts that as economic development increases, environmental degradation will also increase. Moving into an industrial economy, it predicts that we will continue to see this positive relationship between economic development and environmental degradation, such that as economic development continues to increase, so does environmental degradation. It will continue to follow this relationship until it reaches a peak, at which point the relationship will flip, and as economic development continues to increase, environmental degradation will begin to decrease. And this relationship will continue into a post-industrial economy. It's also important to note that the increase in environmental degradation on the left side of the model has a steeper slope and a faster rate than the decrease in environmental degradation on the right side of the model. So among the existing literature, there are mixed reports about whether or not the environmental Kuznets curve, or the EKC, represents this relationship between economic development and environmental degradation. In a study by Balaguer and Cantavella in 2016, it was found that the EKC hypothesis was supported by data using oil prices as the measure of economic development in Spain from 1847 to 2011. In a study conducted by Tao in 2018, the pattern of the EKC was found within individual Chinese provinces, but could not be found on the aggregate level within China as a whole. And in a study conducted by Stern in 2004, it was found that some developing countries are adopting sustainable environmental practices more quickly, sooner to reach that turning point, and in some instances, even performing better than some developed countries in terms of environmental degradation. So my research question is, does the environmental Kuznets curve describe the relationship between economic development and environmental degradation? For my research, I used carbon dioxide emissions per capita as the measure of environmental degradation, as this was easy data to retrieve, and it's typically what is used to measure environmental degradation as a specific pollutant. As my measure of economic development, I used GDP per capita, once again, because of its availability, and also because, as I mentioned earlier, it is typically a measure of economic development in economic studies looking at the environmental Kuznets curve. In addition to GDP per capita, I also chose to use the Human Development Index, or HDI, as a second measure of economic development. HDI is a more holistic measure of economic development, and this is how I'm hoping to be able to contribute to the literature, is by seeing if, using a more holistic view, if we can see the relationship described by the environmental Kuznets curve. My motivation for doing this is that I am an economics and environmental science double major, and I wanted to see where I can bring these two fields together. And upon learning about the environmental Kuznets curve, I became curious to know if we could see this relationship, not just theoretically, but in real data that has recently been published. As a result, I wanted to use the Human Development Index as a more holistic measure of economic development to provide a more modern take on the environmental Kuznets curve, rather than just using GDP per capita, which is only a singular measure of development within a nation. I will talk more about why HDI is a strong measure of development within a country. Furthermore, I think that research on this topic is important because it can help to inform policy decisions in terms of whether or not the environmental Kuznets curve can be supported by the data. If it is supported, this may be cause to allow countries to limit their own environmental impact as they develop economically. However, if we see that environmental degradation does not start to be limited, and we do not see a turning point as economic development increases, then we may need to enforce stricter environmental regulations worldwide. So I want to talk more about the Human Development Index and why I chose to use it as a secondary measure of economic development. It's actually made up of 3 separate indexes: a life expectancy index, an education index, and an income index. Because it contains an income index, it is highly correlated with GDP per capita. However, while also including a life expectancy index and an education index, it provides a more well-rounded view of development within a country. It assigns countries a score on a scale from 0.0 to 1.0. 0 being the lowest level of human development and 1 being the highest level. Furthermore, it breaks down into 4 separate categories for 4 different levels of human development. 0.80 to 1.0, indicating very high human development. 0.70 to 0.80, indicating high human development. 0.55 to 0.70, indicating medium human development, and anything below 0.55 indicating low human development. I will be revisiting this when I talk about the validity of my sample size in representing the population. My data is a panel data set composed of 32 countries between the years of 1990 and 2015. My main dependent variable is carbon dioxide emissions per capita, and my explanatory variables are GDP per capita, HDI, renewable energy consumption, and oil consumption. All of my data was collected from the World Bank and Our World in Data. Additionally, I've included 2 transformed variables of GDP per capita and HDI, where I have squared the variables. This is meant to represent the second half of the environmental Kuznets curve, and this also indicates why there is a negative sign. So the reason for the negative sign is because it is predicted that once economic development reaches a certain level, as it continues to increase, it will begin to decrease the level of carbon emissions per capita. However, before we reach that point, which is represented by GDP per capita and HDI, non-transformed, we're expecting a positive relationship, which explains the positive signs. As GDP per capita increases initially, we are expecting carbon dioxide emissions per capita to increase initially as well. Renewable energy consumption has a negative sign because as it is expected that as we move away from fossil fuels, which emit carbon as they are used, to renewable energy sources, which do not produce carbon dioxide and other greenhouse gases, carbon dioxide emissions will decrease. On a similar note, oil consumption has a positive sign because it is expected that as oil is continued to be used as a fuel source, because carbon dioxide is a byproduct, carbon dioxide emissions per capita will increase. Here are my 2 estimating equations. I ran 2 fixed effects regressions, which is standard practice for an economic study that is looking at a panel data set such as this one. My first regression is a regression of carbon dioxide emissions per capita on GDP per capita and GDP per capita squared. And my second is carbon dioxide emissions per capita regressed on HDI and HDI squared. Both equations include renewable energy consumption and oil consumption as secondary explanatory variables. Additionally, the alpha I and the delta sub t in each of the equations account for any unexplained variation in the country data and any unexplained variation in the time data, respectively. I have also logged all of my variables for three main reasons. One, this is standard practice when analyzing the environmental Kuznets curve in an economic study. Two, it helps standardizes the sizes of the variables so that they're easier to compare to one another, which is something I will explain in the next slide when I discuss my summary statistics. And three, it allows us to analyze the effect of our explanatory variables on our dependent variable in terms of a percent change. By logging the variables and looking at the coefficient in my regression results, I will be able to assess what a 1% change in GDP per capita, how that will impact carbon dioxide emissions per capita in terms of percent change. So here are my summary statistics. As you can see, there's a lot of variation in the size of the mean and the minimum and the maximum of these variables, which is part of the reason why I used a log transformation to help standardize them. I also want to point out that the mean HDI was 0.78, while the mean HDI for all HDI collected thus far for all countries involved in the study is 0.65. So what that tells us is that this study is looking at a data set that is skewed to the more highly developed side than the entire population. This does tell us that our data may not be completely reflective of the entire population, and more countries would need to be added to balance this out. However, based on the minimum HDI, which is below 0.55, we see that there is at least one country that is of low human development, and the maximum being above 0.8, we know that there's at least one country that is considered in the very high human development category. So here are my results. Starting with the first regression, GDP per capita, we can see that all of the variables are significant at the 1% level. Furthermore, all of the coefficients have the signs that we predicted. GDP per capita has a positive sign, GDP per capita squared has a negative sign, renewable energy consumption has a negative sign, and oil consumption has a positive sign. We can interpret this by saying that a 1% increase in GDP per capita leads to a 0.41% increase in carbon dioxide emissions per capita for a given country at a given time. The R-squared value is rather small, indicating that the data does not account for much of the variation within this model, which indicates that we may need to add other variables to account for the variation and include a larger sample size. Currently, the sample size includes 832 observations for both regressions. Moving on to regression 2, HDI is significant at the 10% level, and HDI squared, renewable energy consumption, and oil consumption are all significant at the 1% level. Once again, the signs reflect the predictions. Log of HDI has a positive sign. HDI squared has a negative sign, renewable energy consumption has a negative sign, and oil consumption has a positive sign. The R-squared value is slightly larger, but still small. Once again, this reflects that there's still a lot of a variation in the data that we cannot account for. So once again, because all of the coefficients are significant at least the 10% level, and most of them are significant at the 1% level, and the signs match the predictions, overall, we can say that for both regressions, using GDP per capita and HDI as our measures of economic development, the EKC hypothesis was supported. However, because our R-squared values were small, it does not account for all the variation, and more research would need to be done in order to reach a more solid conclusion. Additionally, some future work that could be done would be providing a sample size that is more reflective of the population based on the distribution of HDI. As I mentioned earlier, our HDI for this sample is skewed to a higher level of development than for the population. Additionally, I think it would be interesting to examine the environmental Kuznets relationship within individual types of economy as specified by the specific model that we discussed earlier. such as using the different groups that are laid out by the Human Development Index. And finally, I think it would be interesting to do some research using a more inclusive variable for environmental degradation. While carbon dioxide emissions are what are typically used, there are other measures of environmental quality and environmental health within a country, such as land use, primary type of industry, population, and number of cities, among others. And I think it would be interesting to include those in this kind of research. Thank you for watching my presentation, and I hope you learned something new about the relationship between economic development and environmental degradation.